Our next speaker is Roberta Sinatra, who is assistant professor at Central European University in Budapest. A theoretical physicist by training, Roberta is working at the forefront of network and data science, developing novel theoretical methods on social phenomena and human behavior. Many know her work, which was published recently in Science, on the Science of Science and the Collective Phenomenon of Success. Please welcome Roberta Sinatra.
Thank you, Philip. And for those of you that have seen already the first couple of slides, please stay with me until the end because there is more to come. Okay, I want you to think of the most famous piece of art in the world. Really the first thing that pops into your mind. Now, I'm pretty sure that most of you have thought of the Mona Lisa. And who did it? Okay, many. And indeed, this is the most famous, the most visited, even the most parodied piece of art in the world. However, a few centuries ago, Leonardo da Vinci, and probably no art historians, would have predicted what happens every day at the Louvre. And if you've been there, you know what I'm talking about. There are constantly crowds trying to get a glimpse of this painting. But this was not always the case. A few centuries ago, the fame of Mona Lisa started only at the beginning of last century, after it was stolen. And it took 3 days to the museum to realize that the painting had disappeared. So the story of the Mona Lisa, the story of the theft of the Mona Lisa, illustrates the difference between performance and success. So here, the physical painting of Mona Lisa is an instance of Leonardo da Vinci's performance. On the other hand, the crowds that gather every day at the Louvre are a reflection of how society perceives that performance. So in other words, performance is about what you do. It's your painting, it's your work, it's a formula, right, Vito? It's an individual attribute. However, success is about us. It's about about what we think your performance is. It's a reflection of how society perceives your performance. So it's a social phenomenon. And why is this important? It's important because the link between performance and success is not really understood. We know there is a link, we know they are intimately connected, but we don't know how. And there are actually experiments, like the one by Dodds, Salganik, and Watts, that shows that this link is not trivial at all. And I want to talk about the importance between performance and success in tackling a specific question, but to keep in mind that this is important in many creative fields, like in art, in business, and we will see in science. So I want to see how the connection between performance and success is important in tackling this question. And this is a question that, as scientists, we are interested in. The question is, what will be the next great discovery? And the desire of predicting discoveries pervades probably all aspects of modern science, of the academic enterprise. So funding agencies want to invest taxpayers' money in the most promising research. Or editors want to publish the most impactful research, so the papers that will have the broadest impact on the scientific community. Institutions want to get the best hires possible, promising scientists. And I guess even the Complexity Science Hub wants to hire the next Nobel Prize winner. Is that right? No? Well, but for sure high achievers, right? So, and what is a way to tackle this question, a quantitative way to tackle this question? It's by using data, and specifically data about publications and citations. And full disclaimer, I'm one of these people using these databases. And so if we have databases, large databases with publications and citations, what we can do is using measures, impact measures. But there is a catch, there is a problem with that these measures assess the past. They are not predictive of the future. So they are good at predicting discoveries for which we have collected already a bit of evidence, for which we have data. If you want to visualize it in a way, they are good at predicting discoveries for which we have already collected a lot of pieces of the puzzle, and we just need that key piece to put the puzzle together. So these are discoveries like the measurement of the Higgs boson or the detection of the gravitational waves. However, these measures fail to predict discoveries for which we have little evidence, for which we are missing data, for which we need first the first piece of the puzzle. And these are discoveries like the penicillin or the cosmic microwave background. So, first problem of this approach is that vast amount of data is useful, but it's not sufficient. And if we just follow the data, we base our approach just on data, what we can do is funding or investing more on science that is expected instead of science that is unexpected. But there is a second problem. So, and it's illustrated well by the discovery of the penicillin, which revolutionized medicine. So the penicillin was discovered, but it was used only much later, only 15 years later. The medical community started using it, embraced it. Now you can have a parallel universe where the discovery of penicillin is not embraced by the scientific community and it goes unnoticed, and you live without penicillin. So so it's not sufficient to have a discovery, but you need a community to acknowledge it and to follow up on it. So again, there is a difference here between performance and success. So what is the second problem with this approach? That we detect discoveries through their success, through their impact, not because of their face value. So what is that we can do? How do we tackle then this question in a way that brings benefits for the society? So first, we need to acknowledge that this question is not the question that we're asking, but this is the question we're asking. So what will be the next great high-impact discovery? Because what we are doing is detecting discoveries through their success, through their impact. So we need to acknowledge the social nature of success measures. And once we do that, as complex scientists, we have tools, we have theories, we have even an instinct to analyze this social phenomenon behind success. And for example, we can find that we've shown that in careers there is a good amount on luck in becoming successful, or there are repeated success, like there is a hot hand phenomenon. And these are all things that can lead us to better predictions that are not simple black boxes. They are not simple data driven. But the bottom line is that we need to understand the link between performance and success. We need to explore it, and we need to study success as a social phenomenon and reverse engineering how it stems from success, from performance. And complexity science can and has to unveil the laws behind social phenomena leading to success. And we need to understand it. We need to understand the mechanisms and the biases behind this social phenomena, because if there are biases, then there are biases in success that distort the performance measure. And how do we do it? I think we do need data, but we need also models and theories, so we cannot have just data-driven approaches, and we need to reach really a profound understanding. And I think that this profound understanding needs also experiments, cannot be done without experiments. So we have to put all these pieces together. And I want to stress that as complex system scientists, we have the moral duty to understand the connection between performance and success, because we live in a society that is using increasingly success measures as a proxy of performance, but we have no idea how success and performance are connected. Thank you.